Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the February 2016 Grade 7-8 Contest Question 13, which also came up in the Grade 9-10 and 11-12 contests. So the question is, 5 students regularly start for the school basketball team. If Jasmine and Eve do not sit together, in how many different arrangements can all 5 students sit on the bench? Now, we could find one arrangement by having all 5 students taking a seat on the bench at the same time, with this added condition that Jasmine and Eve cannot sit beside each other. But this wouldn't tell us anything on how to find all different arrangements of students sitting on the bench. So we will introduce a procedure which will generate all different allowed arrangements. Alright. Now, what differs from our procedure and this original method is that instead of having all 5 students taking a seat on the bench at the same time, now we will have each of the 5 students taking a seat one after another on the bench. Now, we can do this because the question only asks for the final seating, and it does not matter in which the order these 5 students take a seat on the bench. Now, we will use this to our advantage, and we will pick an ordering in which one of the 2 students, Jasmine or Eve, so we will just say Eve, will be the last student to take a seat on the bench. So the 5th student to take a seat on the bench. Alright. Now, this is the best, it's the easiest for us because there are no constraints on the first 4 students. Alright, now let's do this. So for the first student, there's just an empty bench, so there is one option to sit. Now for the second student, there are 2 options where to sit, either on the left of that first student or on the right. So we have times 2. Now for the third student, there are 3 options to sit for each of those 1 times 2 options for the first 2 students, because he or she can either sit on the far left, between the 2 students, or on the far right. Now, for the first student we had 1 option, the second student 2 options, third student 3 options. Now, for the fourth student there are 4 options. So for each of these 1 times 2 times 3 options for the first 3 students, there are now 4 options where to sit for the 4th student. And now for the 5th student, which we will just say is Eve. Now, there would be 5 seats that are available, but only 3 are allowed because from the question it says Jasmine and Eve cannot sit beside each other. And no matter where Jasmine sits on the bench, there is a spot to the left of her and to the right of her open. So instead of having 5 options, there are now just 3 for each of the 1 times 2 times 3 times 4 options for the first 4 students. Okay. Alright. So the total number of different arrangements is 1 times 2 times 3, which is 6, times 4 is 24, and times 3 is equal to 72. Now, of course, this is just one order in which these 5 students take a seat on the bench. So instead of having Eve or even Jasmine being the 5th student to take a seat on the bench, they could also be the 3rd student to take a seat on the bench, or even the 2nd. And the result will still be the same because, again, from the question, we only care about the final seating. So the order in which each of those 5 students take a seat on the bench, again, it does not matter. So we would still get this answer of 72. Alright, so this would be option B. Now, the key to solving this problem was introducing a procedure which could generate all the different arrangements, and also realizing that the order in which each of the 5 students taking a seat on the bench did not matter. Therefore, we could use that to our advantage, and then picking an order where one of the two, Jasmine or Eve, would be the last person to take a seat on the bench. If you'd like to know more about this contest, please feel free to visit our website at cariboutest.com.